Believe it or not, we're live. Okay, so it's gold what we have to achieve. Oh man, did I scream at some individuals last hour about being neat. Okay, this is just like geometry proofs. Everyone say it. Okay, it's not as bad as that. Now, a geometric proof, you write a statement, and then you have to give yourself valid reasoning why you write the statement. I won't do that second part. This is what I was talking about what other math teachers do. They do that. You know, they make their students make a statement, make a change, then off to the side they make them write a reason why they made that change. I won't do that, but what I will make sure you do is what I have in yellow here. That's the trade-off, and I guarantee you what I've written here in yellow and what you need to do for me is a lot easier than writing sentences to prove what you did. Now, other teachers may say I'm a bad teacher for not making you do that. But if I can understand your logic from one step to the next, and it's very clear and concise, the changes that you make, I'm fine with that. I think that is math writing. And that's what I'm concerned with. This is one of the most beautiful things, a student that is able to do an identity correctly, mathematically, with nice, concise work. One of the most beautiful things that I get to grade. I'm being honest. Okay, so that's why I'm just going to hold you to what's written there. So this is what you're going to do in yellow. This is the law, if you will. What's nice about this is not what happened to you in 5.1 day 2. 5.1 day 2 just said simplify an expression. Well, you didn't really have, you just had to try something and then hopefully you got something real simple. And sometimes you didn't, right? Sometimes you got something that, am I done? You know, I don't really know if I'm done or not. Well, here you have an equation, which means you have an equal sign, which means you have the answer. You know what you're supposed to get. So you know what's supposed to happen. And it's not necessarily simplify. So what you will do is start with one expression on either the left side or the right side. Make a choice. But once you make that choice, you are stuck. What is in bold is the rule. And if you don't follow that rule, then go to another class where they make you write sentences and describe every step that you have done. And I'll tell you what that other class still does, still has this rule as well. Because every CAT teacher does the same thing. I'll tell you this. We were supposed to have a quiz today. I couldn't even say it. I almost said quiz with an L. I don't even know what that is. Because you were supposed to have a quiz about knowing your Section 5.1 identities. Because you're supposed to know those. You're supposed to know those like the back of your hand. All right? And if you don't, and you can't memorize, then that's also an issue with this, not doing well in this class. An inability to memorize certain things. So, number one, don't write all this down. This is on page 207. You will not have time to write all this down. In fact, I'm going to make sure you don't have enough time to write this all down. So don't even try. Okay, number one is learn those dang identities in section 5.1. Here, let's play a game. Sine squared, come on class, plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. Listen to your peers. You are behind your peers, those that are saying this stuff out loud. Cotangent squared, secant squared, plus 1 equals secant squared. And then, here we go. Sine of negative theta. Uh-oh. Negative sine theta. Nice. Secant negative theta is equal to secant of theta. That's one sine and wrong. Secant and cosine, it doesn't matter. The other ones it does. So obviously tan of negative theta, negative tan theta. So these people that are saying these stuff out loud, they would have done fine on what I should have had as a fill-in-the-blank quiz. And those that did not say a word and don't know them, you're in trouble. I had someone last hour with no cards, though, so they're working on it. So you work on it. Otherwise, you're in trouble. Okay, then step number 2. Again, I'm just going. You're not going to have time. This is on page whatever it's set up there. Try to rewrite the more complicated side. You stay on that side, too. You don't flip-flop sides here and there. And I'll be more precise what exactly I need. This is one of the most golden steps, but it's not always the case. Whenever you don't have pluses and minuses, if it's like times, a bunch of trig stuff, almost always turn it all into terms of sine and cosine and see what happens. See if things start canceling. So this is a golden step right here, but not always the end game. Sometimes you will do stuff, it doesn't work. You got to erase and start over and try something new. And only the students that have rigor and that, treat this like it's solving a puzzle and are interested. That didn't work. And then have the gumption. Listen to all these words that I'm using. The gumption to actually erase their work and try something new. Those are the ones that succeed. The quitters are the ones that don't. And actually the sloppy writers, which we'll get into that as well. All right, number 4. This really does with what you did yesterday. Algebra operations, we'll just call it. In that, let's zoom in on this. You might want to write this. Those that don't know how to get a common denominator, let's say. A lot of times when you have a fraction equals a fraction plus a fraction, the idea of getting a common denominator is key. So it's just like I asked this last hour. What's the common denominator with 1/2 plus 1/3? What's the common denominator? This is one of those easy ones where they don't have anything in common. The common denominator is just 6, 2 times 3. So what do we do on this? We multiply by 3. I'm not teaching grade school. And yet again, I am, aren't I? Because I just showed you how to get a common denominator there. So in the other one, we're missing a cosine. In this one, we're missing a sine. And the whole idea of getting a common denominator is to add the numerators and put them over a common denominator. And then see what happens next. So you don't know what we're doing yet because I haven't shown an example. All right, so all this is kind of out in the air right now. Sometimes, this is crazy, the reverse of this has to be done. Oh, this is craziness. And it all depends what you're looking at. All right, dictates what we're going to have to do. And then, obviously, substitutions. This is really all about substituting. And I ended the notes with this. Do you remember this little x times y plus 2z? Hey, but then your teacher said x equals 2, y equals 3, z equals 4. What could we do? Starts with an s and ends with substitute. I don't have enough time. So what did I put in for x? Oh, are you okay? I just stepped on a student's shoe. He's going to sue for all my money. You put in a 2 for x, a 3 for y, a 4 for z because they're equal, so I'm allowed to substitute. You're going to find out this is all about substitution. And what's the key to what you can substitute? Section 5.1. And that chart that I just told you have to memorize. So let's look at this one. We can verbalize this real quick. And sometimes it's, better to think about both sides and then make a choice what I want to do. What is 1 over cosine squared? Secant squared. What's tangent squared plus 1? I have to make a choice, though. Which side do I want to work with, the left or the right? Well, if we work with the right, the next step would be make this secant squared. And then the next step would be make this tangent squared plus 1. And then this is how your work would look like without all this words in the middle. Sorry. That's how we're going to do this, and I'll show you that later. Or I could work with the left side. I'm rambling now. What's tangent squared plus 1? Secant squared. And then what's secant squared? What's secant squared? That's how your work's going to look without all that writing in the middle. So actually, this is I just did 2 substitutions in each case. Which side did I work with? I worked with either one, and I got the same results. One side equals itself. So I proved what I needed to prove. And I'll do better explaining that when we actually get into examples, the key terms for that. Then this is weird, wild, wacky stuff. And then actually somebody walked out of the door because they had time to ask this question. They saw a number that was assigned. How do I deal with something that one of the denominators is 1 minus sine x and one of the denominators is 1 plus sine of x. Notice I said denominators. So if we have denominators with an addition statement, what did I just say you should get? Common denominator. So multiplying by 1 plus sign and 1 minus sign gives me 1 minus sine squared for both of them. What's 1 minus sine squared, everybody? Well, now that was a little tougher, but what is 1 minus sine squared? Do you hear your peers just say cosine squared? All they did is reshuffle the cosine squared plus sine squared equals 1. And those that their heads spinning right now, you're not on the bus for knowing what section 5.1's identities are. You're behind. Okay, it's time to go now. Leave? I wish you could, because then I could eat my lunch. I'm hungry. I like you guys. I just want to eat. Now this is management decisions. Sir, back there, you better pay attention. That's if you're watching the video and not paying attention. I just woke you up. What's that noise? Okay, here's what I mean. You are given the answer. This is not like 5.1 day 1. So this is why I'm going to make you treat this like a geometric proof, where from one step to the next, there is complete and total, I can understand your work. So A, you can't be a sloppy pig with your writing. And anyone that's sloppy with the writing, you are in major peril for this chapter if you don't change your ways right now. So some of you have been a bad teacher about making sure you can write neatly. If you cannot write neatly and show logical steps, you are in trouble. Now, it's a very few handful that might be the case. You better change. That's numero uno. Number 2, watch how I do the first example and then emulate this on the homework from here on out, or else you are in trouble. So let's go ahead and do this and talk about what I mean. How do we do a geometric proof, though? Do we write one step over here, and then a second step over here, and then a third step over here, and then a fourth over here? No! That's what I mean about being nice and neat about how you write your steps. We usually go like this, right? 1, then 2, then 3, then 4, right? Yes. That's how we're going to do this. Your homework's going to go down, straight down, until you're done finishing the identity. And then the next one, you're going to start right below that or go to your next half page. And I'll show you how your page will look after I do this first one. Or what? Or what? Or else. Thank you. You're in trouble. All right. You don't do what? Nut. You do what? So who's more complicated, left or right? You make a choice, you stick with it. You're not changing. Okay, so this is how I want you to show this. And you, if you want to write numbers, go ahead. I think that was helpful for students in the past. I never write numbers in my notes. I just do changes. What's tangent? Now, I'm not going to make it 1 over cotan. That doesn't help me. It's true. There's a lot of things that are true, but there are a lot of things that are not helpful. So like we said before, the most common thing, if it's just a simple kind of thing, just change it in sine and cosine and see what happens. So what does that mean secant is? 1 over cosine. Here's what denotes a step. Ooh, I got that alpha. You guys having troubles drawing that alpha? I just fumbled on that. Put an equal sign there. I never put a number, but I put an equal sign there to denote that this is my next step. And then for someone looking at my notes, okay, from here to here, because I have an equal sign, that's step 1 for them. If you want to put a big fat 1 to the left, go ahead. I don't care about that. Now, superfraction people. You actually can get the very next thing happening. What happens, superfraction people? The cosines cancel. So some people may just write this. And notice I didn't write anything over here, because I'll show you what I expect in my class. I don't want you to write sine theta every single time on the right. I don't. Sometimes the right side's more complicated. It's more writing. We don't need it. We are leaving this alone. We are turning this into sine alpha. And always at the end, something equals itself. You will write that. You will not stop short on me. Otherwise, I'll make you write reasons. I'm going to get sadistic. Okay? And you do have to tell me sine over 1 over 1 over 1 is sine. Okay, at least do that. Or, those that don't understand the canceling of the cosines, you will just have an additional step. All right, so let me go back and rewrite this, get that out, and get that out. You would have to do this, those that don't understand your fractions well enough. This is the same as what's dividing by 1 over cosine. The same as that is what? Multiplying by cosine over 1. And then you will just have one additional step, show the canceling, and then just extend your line. Just show the arrow. I don't ever even want you to rewrite this. But what you have to say is sine equals sine. And that's your proof. And every step is logical. I will look at this student and say, all right, this student knows tan is sine over cosine. This student knows secant's 1 over cosine. This student knows the cosines cancel. This student knows sine is left over in the numerator. I don't need anything else. I don't need any descriptions of what you did. So now let's talk about what your homework's supposed to look like. Here's a piece of paper. Here's your name, date, whatever. Here's whatever number we start with. Reason 1, 2, 3, 4, done. Here's number 2, reason, done. I better not start 3 down here, so I'm going to put 3 over here. Blah, 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 4, blah, blah. Do you get it? Okay, 1, 2, 3, 4 steps in that order. Or else. Otherwise, I get what's called snakes, and I don't look at snakes. I don't look at step number 1 here, and then some people like to be creative and put this step way over here somewhere, and then this final answer is down here, and it's like a scavenger hunt. Not going to do it. All right, now. I thought I really did a good job last hour talking about this one. It felt different. Oh, way to pat yourself on the back, Mr. S. Okay, what you got to do is, you write it down. And as you're writing it down, which side is more complicated? The left has more stuff, but is the right complicated? Yeah. But what you should do as you're writing this down is to start thinking. This is what the student that does well does. Okay, even though the left side has parentheses and I have options, think about the right side. Like, for instance, what's 1 minus sine squared? Cosine squared. And then what's 1 over cosine squared? So the smart student, I'm not supposed to call students smart. It's illegal now in this Common Core communism. The student that does well on these, whatever, actually thinks a couple steps ahead and then says, okay, now I have a pattern to, go by for the left side. I want to turn the left side into secant squared. And then I'll be able to figure out and get it in 2 steps to be the right side. So honestly, this is not simplify to get the right side, but it's a puzzle. These are all puzzles. And students that enjoy puzzles do actually enjoy these. All right, so there's actually 2 paths to go by on this one. What can I do when you see parentheses? Let's start that one. This is the first way I'm going to do this. This is tangent squared, and then by golly, I know you're not there yet, but you should be. Naughty, naughty. What's tangent squared times cotangent squared? 1. Why? What's the word that describes what tan and cotan are? Reciprocals of each other, multiplicatively speaking. I should not have to see tangent as sine over cosine, and cotangent's cosine over sine. If you have to write it, though, go ahead. You have 2 extra steps. Because it's got to look legible, and it's got to look nice and neat in step format. And notice I don't have to write this. This is what I mean. I don't want to write that again. I know I'm trying to get this equal to this. I get it. But I keep looking at the right side, but not really. What is tangent squared plus 1? Well, didn't I say that's what we wanted to get? Right? How many more steps do I have, though? 2. We got to reverse the steps I thought about for this one. So what's secant squared, everybody? Now, again, why am I doing this? It's only because of starts with an R. No, the right side. Now, I'm unsimplifying, but what I'm trying to get is the right side to happen. And that's what the puzzle is. What's my last step? What is cosine squared, everybody? 1 minus, whoops, that was a little mind I blew a gasket there. We got the left side to be exactly the same as the right side. And I better erase this so I know that that's not a thing, not a fraction line. What do my equal signs represent? How many steps did it take me? 4. That's why I write the equal signs, because I have to read your work. So your equal signs mean a step. That's why we write the equal signs, and I'm not making you write the right side every single time. It's 2 ways. Here's another way. Okay, and again, the only reason I'm doing this, just watch, is there's not only one way to do these. So I will be able to verify that you did this right, by your logic. Like, what's 1 plus cotangent squared? What's 1 plus cotangent squared? So this is another way to do this. This is cosecant squared of x times tangent squared of x. And then you don't do nothing, you do something. So now that I have no plus signs and minus signs, what do you think the next thing I should try? Change everything into or sine and cosine. Don't make this 1 over cotangent squared because that doesn't work with this. What you want to do is make it in terms of sine and cosine because that puts them in the terms of the same stuff. What's cosecant squared? In terms of the same variables, but variables meaning, hey, look at this. So I cancel those. What's next? Give you a hint. What's next? You got this done in one less step, doing it the other way because cosine squared is 1 minus sine squared. One less step, doing it a different way. All right. So there's 2 ways. Not two. There's sometimes many ways to approach these. One of the most beautiful things I get to grade are these things. There's nothing more beautiful than a student that has pretty decent, nice writing, and I could see the logic go down, down, down. It's better than an English teacher reading an awesome 5-paragraph essay or whatever they call it. No doubt about it. I get a lot of bums that they're like this. They're like they're on a test and they're like. And then this is the ones that are like, the ones that get in trouble too, that they think they know everything and they don't have to show anything. Yeah, I know that's, cosecant squared, and I know cosecant is 1 over sine. Yep, I got it. I did it. And that's just the same as, I don't know what the heck I'm doing, but I know he told me that they start as they end, so this is true. Do you understand the difference there? You don't write anything, this is absolutely 0 credit, because we all know what the end is supposed to be. All right, and that's where what I'm saying is imperative. If you think you know everything and you can skip a step, you are in for a rude awakening. Anyway, a little worried. Okay, so now, this one's a strange one. Wouldn't we all agree that the left side is way more complicated than the right? This is where your world is going to get a little strange. Okay, so you see you have a fat subtraction sign here, but it's up in a 1 fraction. But you see over here you have 2 separate things subtracted. So this is why I do this next. Do the opposite of the common denominator rule. That's the way I explain it, because students, you've probably never done this once in your life before. I have something minus something over a denominator. That means I can split this up into 2 fractions using the common denominator rule. And there's my big fat subtraction sign now. This is true. If you don't get it, well then think about reversing this. Isn't tan over this minus cotan of the same denominator tan minus cotan over 1 denominator? So yes, this is true. And what I've accomplished now is I have something minus something, like I have over here. So math structure, understanding fractions and how they can work in reverse. First time you've probably ever done that in your life, though. So I don't expect you to be like, oh, yeah. But just understand that this is something you might have to do often. And then now go ahead and do your trig and treat these individually. What's tan? Sine over cosine. And then you could probably get away with doing 2 steps at once, but save that for later as you get good. What's cotan? I made a fundamental error. You will get marked wrong so quick your head will be spinning. Maybe you did it on purpose. You don't cotan error. You cotan a what? A variable angle. I hate T, by the way. Looks too much like a plus sign or other T's in cotan. What's cotan, by the way? Ah, I did a mistake anyway. You said it right. I wrote it wrong. Cotan of T. What am I doing? I'm all discombobulated thinking about those sophomores. Cosine over sine cosine. Remember, just put equals. Now, the next thing is actually awesome. What is divided by sine over cosine the same thing as? Times what? The reciprocal of sine over sine cosine, which is what? 1 over sine cosine. And then what's cosine over sine? Divided by the same as times 1 over sine cosine. And you don't have much more after this. Actually, we're going to be done. But I'll let that sink in for a second. Look at equal, equal, equal. 3 steps. If you want to put a big fat 1, a 2, and a 3 here, that's okay. Now that you caught up, who cancels in the first expression? Now, you can cross-cancel across multiplication. You can't cross-cancel across subtraction. I yelled at someone for that, remember? Yeah, it was in here too. But can I cross-cancel here, yes or no? And that's the other thing that screws us up. We don't know how to deal with fractions. Don't understand that I can cancel those signs in the first expression. I can cancel the cosines in the second. Guess what I write next? All right, I guess, we could skip this next step because another teacher might be mean. What's 1 over cosine cosine on the bottom? 1 over cosine squared. But I think we should know that. I think we should know this is 1 over cosine squared. What is 1 over cosine squared? Now look at the right side. What is 1 over cosine squared? Secant squared. What is 1 over sine squared? Man, I can't write right now. Drag it. You got the left side to equal the right side completely. You're done. These should usually take no more than 4 steps. A lot of times less. Watch the last examples. Very fast. Now, you may argue with me that the left side is more complicated than the right. But this, again, is the student that sits there and thinks about things before they do it. Like, what's 1 minus cosine squared? Don't write it, but just think about it. What is it? Now, can I turn sine squared into that? Fumble? No, that's hard. But at least I know my path. I want to get this to equal what? Sine squared. That's what we're doing. You don't write it, but you think it. So I think I could turn this into sine squared and then turn it into 1 minus cosine squared in the end. That's the, I can't say smart. Whatever. You can't say intelligent either, I don't know. All these rules. Okay, what's tangent squared? You do something, not nothing. If you still don't know this, what's cosine squared? 1 over secant squared? Why would you do that? Nobody did. I'm just saying. You don't just change things. I'm going to change everything. You want things to cancel. Oh my gosh. What happens? Cosines cancel across multiplication. And then this is sine squared over 1. What did we just say sine squared was? What did we just say? Now again, those that don't know that, this is just another form of sine squared plus cosine squared equals 1. If you subtract cosine squared from both sides, 1 minus cosine squared equals sine squared. So again, this is substitution. This equals that, so I can substitute it. just like the XYZ thing I told you about. Now, you ready for your mind to be blown? Here we go. I think everyone would agree that the left side is more complicated than the right. And don't always just work with the left side. I think every example, I work with the left side because I felt and deemed they were more complicated. It's not always the case. If you work with the right side, then fine. You got to get the right side to equal the left. All your work is over here on the right side, and your equal sign's over here. Work, 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 so on and so forth. That's how the structure should look. Okay. Kind of showing something here. You don't do what? Nothing, you do what? And it's actually not going to present itself right away on this one. This is what I told you is a mind blower. So you do something like, what's secant? By the way, that's alpha, that little fish-looking thing. What's secant? There you go, it's 1 over cosine. Plus, what's secant? I'm sorry, cosecant. I'm getting my 1 over sine. Okay, now, I would really hope we'd get there fast. I would hope you not have to write an extra step for this. What's cosine over 1 over cosine? I would hope all of us could know that this is cosine squared. And I hope all of us then would know sine over 1 over sine is what? Now, if you needed an extra step to prove that, it's got to be squeezed in here. This is cosine of alpha times cosine of alpha over 1. This is sine of alpha times the reciprocal of 1 over sine, which is sine over 1. So if you need to write that extra step, you go right ahead. This is all basic fraction work. That is 4th grade math that I just did in that middle step. That is why I think you can skip this and not have to write that. Those that know their fractions very well. Did we get anywhere? Not really. I mean, does that even come close to the right side? Guess what? You have 2 more steps. What? Does anyone know what the 2 steps are? This equals 1. What did I say? Do what? Something, not nothing. Oh, now I'm really at an impasse. I really don't. Wait a minute. I know secant squared and tangent squared are in this little formula. Aren't they? And then what happens if you subtract the tangent squared? What does 1 equal? So my last step is secant squared minus tangent squared does equal 1. And therefore I produce the right side. Isn't that awesome? So you do what? Something, not what? And then do realize that these are tied together in a Pythagorean identity. Maybe you saw that, you said? Maybe in the beginning you saw that they're tied together in a Pythagorean identity. And maybe in the beginning you said, hey, this equals 1. If I could get this equal to 1, then I'm in good shape. I don't know what else to tell you.